Good evening, ladies and gentlemen. It's an honor to talk in front of this audience. I was invited by Amata, thank you, to give you a short overview about history and development of CLT. Forgive me if I say KLH sometimes, but it was 7 years only KLH on the market until other people came up or other industries came up and to not to copy but to do the same product as we did. Could we start presentation? Somehow it doesn't work. Okay. Ui.
Here.
Yeah. Okay. Thank you. I'm shocked to see my picture. So let me start history and development of CLT using the example of KLH, as I told you. Maybe in short words to my background, I was a small sawmiller, and in my let's talk about history. In 1985, the first patent was given in France for CLT, but it was more or less in theory because nobody had the machinery and the possibilities to produce these large formatted panels in 3, 5 or 7 layers crosswise. So in 93, the first projects from CLT have been made in Switzerland and Germany by Pius Schuller and Karl Moser. Company is Merck, and it was not really CLT, but it was a beginning. And a little similar panels, at least these ones from Merck, Karl Moser, it was done in a different way. And I tried hard to have cooperation with him, but in meantime I'm a good friend of him and found out he hasn't been so far prepared with the technology and he was afraid to make a cooperation. So in '94, current Professor Schickhofer from the University of Graz, he wrote his PhD degree for CLT, but also in theory and in modeling, math modeling. In '95, I personally started a research program with the University of Graz, named Professor Schickhofer, to develop what we called at this time Presta H and Presta V. Presta means Brettstapel and vertical, and Presta H horizontal. And it was a time when Professor Natterer from the University of Lausanne brought the technology of nailed panels from the USA to Europe. And myself, I produced this kind of panels and did also some projects with it. And for this case, I also founded a wood construction company, carpentry, and because nobody liked to mount this kind of product, because the carpenters are very traditional people and they are proud for their work to make very complicated roofs and stuff, but they never would like to be just mounting something. So I forgot the press. So at this time I also had this contact with a German company, Karl Moser, and found out this would be the right way to glue the boards crosswise to avoid shrinkage and growing, because with the projects we did with the nailed panels, we had really huge problems with the shrinkage and growing, because as soon as you bring this kind of panels in a very dry environment, and that happens in Austria or in Middle Europe, when you bring it inside the building in the heating period, because in the heating period you have maybe air moisture of 20%, even below, and that means moisture in timber is 6%. And even we had it kiln dried, it's still shrinking, and then you have the gaps, and you cannot really use it for this kind of buildings. And actually it was a strange use, because in the United States it was used for bridges, mainly in temporary bridges for forest roads. And as soon as we had, same time, I developed a press technology to produce this kind of panels, because there was nothing on the market. And we did the first panel really in a garage. It sounds funny, but it is, as you can see here. And we found really some, let's say, crazy people. First was an architect. He was very, very innovative and still loves timber, and he always wanted to use this really natural, environmental friendly material in his buildings. And so we did the first. And second guy was an engineer. He came from structure design, but from general structure design, concrete, steel, and timber was not so popular at this time. The chair on the University for Timber was only founded 3 or 4 years before, University of Graz. And the third important man was this one with a photo apparat. He was an investor who was brave enough to invest in this wooden residential building. During this project, we did a lot of testing. We destroyed approximately 100 cubic meters of this kind of panels to find out all the property, the E-modulus, strengths, bending, stress, and as I said, it was a project over a year, and really with a lot of results. This is this famous first residential building. The panel we produced at this time haven't been very nice, as you can see on the right side, but it worked. And the size of the panels has been 3 by 6 meters, up to a height of 6 meters. 50 centimeters. Somehow there is a mess. So in 1997, when the research project was already almost done, I had maybe illusion that this will be a great product, and was a little afraid to do it by myself, all alone. So I invited 2 other people, 2 other sawmillers, to join me with the company. And so in 1997 we founded KLH, and in 1999, after 2 years of trial production, we did real production on the same place it's still situated now. Yeah.
Can you stay there because the streaming is here?
Uh-huh. No problem.
So people can see
You love to push me around, huh? So immediately after the production has been established, we started to be active on the European market. A very important market at the beginning was Italy. There we found a very innovative carpenter, builder, and he with very nice architects did his first projects, and it was kind of an eye catcher. For example, the left structure is all done in CLT, and also the white stuff, the box, is done in solid panels and was plastered afterwards. Another project in France, it was an office building showing about the possibilities. The core was done in CLT, also the slabs, and in combination with glulam beams. Another very nice project done in Sweden. It's a King's Riding Hall with a span of 36 meters. The roof structure is only done with CLT panels and in combination with steel rods and beautiful glass facade. It's situated in south of Sweden and owned by the King's family, Swedish King's family. Another project in Stockholm. It's an old factory building, and they remodeled it to a museum, and we had to do the lift shaft. And they couldn't do it in they could have done it in concrete, but very, very expensive, and it was a kind of rounded lift shaft, cladded with copper outside, and it was very well accepted. So I don't know what happened with this. In 2004, we got a big order for the Olympic Games in Italy, in Torino, and for this project we had to produce about 700 single bedrooms for the staff, for the volunteers, for the Olympic Games, and it unfortunately it had to be removed after the games, but now the units are used in student homes and hotels and so on. I don't know why all the times this. Now about KLH. Right now, the production capacity is about 850,000 to 100,000. That's a mixture. Cubic meter, of course, not square meters. And last year the volume was 900,000. The turnover was 45 million euro. The number of employees is approximately 160, and the export quotation is around 70%. The European markets, and that's not so interesting. It's a little old. So, laminated solid timber, the product, crosswise glued lamellas in spruce, could be in pine, of course, also, and is also done in Austria in pine. Probably almost 10% of the production is done in pine, and mainly in treated pine for overseas departures for France. So it's a large size structural element for wall, ceiling and roof, maximum dimension 16.5 meter long, 295 width, and thickness maximum half meter. Then you can produce non-visible surfaces, industrial visible surfaces. So it means it doesn't necessarily need cladding in an industrial building. And of course, domestic visible quality if you would like to keep the wood visible in an apartment or in a standard house. Different layers and custom-made production. Every project is almost unique, so you cannot produce in stock. Everything is just on time, in time. Also on site. Machinery is standard European machineries. The high pressure is 6 kilo per square centimeter. We're using a PUR adhesive. The main thing about it, it is absolutely formaldehyde free. So you're using for cutting you use normal CNC machinery. So did some application for this kind of panels, of course. The first high-rise building was done in London with 9 floors. And this was the first project we won against concrete. And the most adventure in this building, it was a saving on time because they calculated in concrete, in best case 9 months of erection, and we did it in 7 weeks. And site was very narrow, and so we could avoid a lot of costs. Of course, parallel, we had to do also certification, from the European certification to German, and we always talk about Europe, but you have to have it in France, you have to do something in Austria, and also probably wood is burning different in Switzerland and in Germany. And yeah. Current situation, main production for CLT is in Middle Europe, Austria, Germany, Switzerland. And here, that's maybe an interesting thing. When we started, it was almost zero. And you see the curve going straight upwards. And now we have reached 1 million cubes in Europe. Actually, faster than expected. So thank you for your attention. Hopefully it was not too boring. And sorry for my poor English.